Hello Geometry, sorry I couldn't be in class today. The goals today, we're going to be discussing the homework problems that I assigned yesterday in class. So if you were gone, we did get new homework yesterday. It will be due Monday, March 5th. That's coming up this coming Monday. Obviously you can see the problems here on the screen. Most of the problems are finding interior and exterior angles for a polygon. I added an extra stipulation, as you can see below the problems. Anytime that your problem has a diagram, a picture that goes with it, you need to find the number of diagonals for that diagram. So you'll have to follow the book directions as normal, so find the interior angles or exterior, but anytime your problem has a diagram, a picture, you also have to go one more step and find the number of diagonals with it. But that's only with problems that have pictures. So we're going to jump right in. We'll do 2 examples of our homework problems, so that'll hopefully alleviate some of your stress if you don't know quite what is going on here. But then we're going to jump into the next section, which is 6.2, and introduce parallelograms. Now, we've discussed what the word parallelogram is, so we'll go through that definition one more time. But the goal today is to kind of talk about what we're going to be doing Monday with them, so you can kind of get an idea of the type of problems that we're going to be seeing on Monday. So we'll jump right in. Let's do our first homework problem here. So this is one of the problems that could be potentially in your book, so I might have assigned this one. Hint, hint. This problem in particular, what it asks for you to do is find the interior angles on the diagram. So it says find the value of x that satisfies the following diagram. So we need to use that first theorem, 6.1, as you can see on my screen, which is this one right here. This formula will help you find what the sum of the interior angles are when you add all the interior angles together. That's important. We need to find that number first. So my formula says 180 times n minus 2. We're going to replace this n with the number of walls. Well, this picture has 4 walls. You know, it's a quad. It has 4 sides. So we're going to plug the n being 4 into this problem. So when we do that, we get 4 minus 2, which is 2. We're going to take that times 180, and we get 360. This is what all the interior angles on this particular picture should add up to be. That number is the number we're going to use here in a second. So now, the actual picture itself has 4 angles. These are the angles that add up to be 360. So we're going to add them up. So the first x is a 1x. So 1x plus 2x plus 3x plus 4x in no particular order. And that has to equal my 360. Now, actually doing the work here, we add these up. We have 1 plus 2, which is 3. 3 plus 3 is 6. Plus 4 is 10 x's. And that equals my 360. And we're going to divide this 10 across, and we get x is a 36. So that was the first goal of this problem, was to find what value of x satisfies the condition that gives me my interior angles. If you want, you could plug the x back in. You don't have to. That is not one of the questions that they ask you to do. But that 36 is the number they were looking for. Now, since this problem has a diagram, we do also need to find the number of diagonals for this picture since it has a diagram. So let me get rid of my markers here. Diagonals, remember, are when you take one of the vertices or vertex and you connect it to another vertex that's not already attached to it. So right now I already have one diagonal drawn, and then you try to figure out the total number. Well, this problem is pretty easy. You can figure this out, that there is 2 diagonals here, right? That's the total number of unique diagonals. But we do have a formula for it, right? You can actually see it right here. This formula will give you the number of unique diagonals. So since this problem had a picture, we do have to do this one as well. So there's 2 parts to this problem. So let me get rid of the work that I just did a little bit ago. So the formula here, it says n times n minus 3 divided by 2. So the number of walls we have here is 4. So we're going to plug the 4's into these n's. So we have 4 minus 3, which is 1. And we're going to take that times 4 and divide by 2. So 4 times 1 is 4. We're divided by 2. And yes, this formula does show that there is 2 unique diagonals without repeating them, which is what my picture shows. You do not have to draw your own pictures or draw the diagonals, because some of the problems have a lot of walls. You know, if you have an octagon, there's quite a few diagonals in those. So use the formula, figure that out. So this is the second part you have to do in these problems if they have a diagram. But you also have to follow the book directions. Okay, let's do another one. But again, this problem originally was about interior angles. So let's go to the second problem today. So now if you're looking at this one, it's talking about exterior angles. So it says find the value of x. It satisfies the following condition. This picture is obviously a quad. It has 4 walls to it if you want to count the walls. They've extended them to show you the exterior angles. Well, it doesn't matter how many walls you have. Any type of polygon, the exterior angles will always sum or add to be 360. That's the magical number. It doesn't matter if it's a 23 gon, a 100 gon. It doesn't matter. They always add to be 360. So my angles here are 2x, a x minus 1, a x plus 10, and a 79. Now, when you add up all of these angles together, you should get 360. That's what that theorem is saying. So we're going to actually add these together. So if I add all the x's, now these x's have 1's in front of them. So that's 1 plus 1 plus 2, that's 4 x's. If we add the 10 plus 79, I get 89. And if I subtract the 1, I get 88. Again, I'm just combining like terms, the -1, the 10, the 79. So hopefully that makes sense. Now, the goal here, we have to solve for x. So we're going to need to potentially use calculators on these because these numbers get pretty large. Now, if you don't need the calculator, that's fine. Some of these numbers are pretty straightforward. But if you actually type that in, 360, and we're going to subtract the 88 across. So if we subtract this over, we get 272. Again, type those in your calculators and double check that you're typing it in right. And then the last step here is we're going to divide the 4 over. So if you take 272 and you divide by 4, we get 68. And that's my x. 68. All right, hopefully that made sense. So that's the first steps. You had to find the exterior angles and the value of x that satisfies the condition. So now, the next part, since this problem also has a diagram, we have to figure out the number of unique diagonals. So we already know the number of diagonals. We already did the quad, but again, you'd have to use the formula again. Without drawing, you wouldn't need to draw these, but you have to plug the number of walls into the ends here and actually solve. We already know since it's a quad it has 4 because again you're going to go 4 times 4 minus 3 and divide by 2. Again, that was 4 times 1 divided by 2, which turned out to be 2. We already did that one earlier, right? That's the number of diagonals in that picture. Again, if it has a diagram, you have to find that as well. Okay, so that's basically what some of your homework problems look like. I just wanted to pick some that had pictures on them so you know what you had to do. But you have to show all your work. Try to show what you're doing here because some of the problems are pretty straightforward. That's pretty much it. There's a couple problems they ask you to find one angle by itself. Some ask you to just find what they all add up to be, so you just use the generic formulas. But the last thing I want to talk about today is what we're going to on Monday. On Monday, we're going to be talking about parallelograms. This is a picture of a parallelogram. The notation that your book uses is this. That's the notation that they actually use. That is, they draw a mock picture of a parallelogram, then they put the 4 letters in order. And what I mean by order is that they spin clockwise or counterclockwise, so you can start anywhere you want. You can write that as B, C, D, A if you want. But that's how they write parallelograms as notation. Goals on Monday is that we're going to be going through 6 theorems. That's a lot of theorems. We're going to go through 6 theorems that deal with this picture. Now, the definition of a parallelogram, it's a quad, right, 4-sided figure that has opposite sides being parallel. So if you're looking at this picture, these are parallel markers, right? It doesn't mean that the walls are necessarily equal to each other. It just means that they're parallel, that if you were to extend them straight, extend them further, the walls would not intersect. They would not touch in these areas. They're equally spaced. So the things we're going to talk about is that on this particular drawing, that knowing that property, that the walls, when you extend them, are equally spaced and they won't intersect, it does force certain things to be the same. Like by looking at this picture, it looks like certain walls are equal, which is the case. I mean, that's one of our first theorems. Certain angles are the same on this picture because parallel implies certain angles. So those are the things we're going to be looking at. Also, there's little properties that apply for the diagonals. So that's why we've been bringing that word up and why we've been talking about diagonals when the book didn't really discuss them. These are the things we're going through on Monday. So be prepared. We'll do a PowerPoint on Monday. We'll do a lot of definitions, a lot of theorems. We'll prove quite a few of them because I like to prove the theorems just to show you why they work. But just kind of be mentally prepared for that. So that's the only thing I want to talk about. I just want to introduce what we're doing on Monday. So today, your goals. try to work on your homework. You have plenty of time. You have the rest of class today to work. Try to keep the talking to a minimum unless you're actually talking about the homework itself. But remember, anytime that any of these problems have a diagram, you need to also find the number of diagonals for it. Read the directions. Each problem, you have to follow the book directions, and then also do the extra part if they have pictures. Good luck. I'll see you Monday. If you have any questions, do not be afraid to ask. Monday we'll discuss before you have to turn it in. Okay, good luck.